Let's go ahead and start up Jupyter Labs and start exploring the interface. So I'm going to go to a command shell, and then I'm going to cd into a directory, change directory into a directory where I have my notebooks or where I want to put my notebooks. And so I've created a notebooks folder under my user directory. So I'm going to cd into there. And this is where I'm going to launch Jupyter Lab from, and that will give me direct access to the files inside of the notebooks folder, but not outside of it. So to start Jupyter Lab, which I installed in Unit 1, I just type Jupyter Lab, and if your path is set up correctly, it should start up a web server with Jupyter Lab, and then it will launch a browser window. And it actually started up a new tab in a browser window that already had a lot of tabs in. So to keep this a little cleaner, let me just go ahead and start this up in its own window. So this is the main interface for Jupyter Lab. And what I see in this pane is basically a file browser. It shows me starting from the root, which is where I started up Jupyter Lab, all the files and folders underneath that root directory. And if I had launched Jupyter Lab in some other place, like C:, I would have access to all the files on the machine. Or if I had done it, for example, from C:/user/mark/documents, then I would have access to all the documents and subfolders under document and so on. So the first thing I want to do is either open an existing notebook, and I have some in my folder already, or create a new notebook. So I want to create a new notebook for this example, and I see under the Launcher tab that there's Notebook using Python 3. That's the one we want. There's also a Python console window if you wanted that. You can also There's a text editor you can start, a markdown file, which is basically formatted text, and contextual help. So I'm going to start a new notebook file. And what I see here in this interface is a main notebook. So in Jupyter Lab, you can have multiple notebooks open at the same time, and then each notebook is a collection of cells. So a cell can be one of two things. It can either be a fragment of code that you can evaluate that's going to affect the runtime environment the same way as it does in a read eval print loop for Python, or it can be markdown, which is basically formatted text or things that can be displayed as formatted text. And so most of what you're going to do when you develop a notebook is add new cells to the notebook and add code to some cells and markdown to other cells. So let's start by giving this cell, actually let's give the notebook a name. So I'm going to right click on this tab where it says untitled.ipynb. That's an IPython notebook. And I'm going to rename this notebook from untitled to let's do module 4 example.ipy notebook. So we'll rename it. And then you'll also notice that under my File Explorer pane, I now have a module 4 example.ipy notebook. So changing the name of this tab also changes the name of the file on the file system. Now, in addition to all these settings, there are some keyboard shortcuts for most of this thing. So most important one probably is this one, Control Enter, and that's run selected cells and don't advance. And then the second most important is this Alt Enter, because that's run selected cells and add a new cell below where you currently are. So let's take a look at those two things. I'm going to start by changing this cell to markdown. So it's currently code by default. I'm going to change it to markdown, and then I'm going to go ahead and add a line of markdown code. So a hash sign at the start of a line is a header line, and one hash sign is a level 1 header. So this will be an example notebook. And then to run this, I'm going to press the control key and hit enter, which is going to run the markdown in this cell, but not advance to the next cell. And so what I see is the formatted result from running that markdown cell. Now, if I want to get back into edit mode to change this markdown, I can double click on the cell, and that puts me back in edit mode. So this time what I'm going to do is I'm going to press Alt plus Enter. That will run this code, and then we'll create a new cell below it and advance me into that new cell. So Alt plus Enter, I see my example notebook, and then I get a new cell, which is code. So this time let's create a level 2 header. Let's make this markdown. We'll create a level 2 header. And here are my imports. And then I'm going to run this in advance using Alt plus Enter. And then this one I'm going to leave as code, and I'm going to add some important imports. So generally, there are 5 or 6 things you're pretty much always going to want to use when you're working with pandas and matplotlib and so on. I'm going to start with PyODBC, so I can read stuff from a SQL database. And then I'm going to import pandas as PD, which is just a standard abbreviation, and import matplotlib.pyplot as PLT. And then you might want to import Seaborn as SNS, and you might want to import NumPy as NP. And that's probably more than we're going to need for this. We're probably only just going to need PyODBC and pandas. But anyways, I've entered that stuff, so I'm going to go ahead and Control Enter to execute this code here and not create a new cell under it. So I didn't get any errors or any output, but you'll notice that after a while, the number inside these brackets was updated to 1. That means this cell was the first thing to get executed in the kernel. And this number will become important when I start executing these cells out of order, because you sort of have to know the sequence that stuff was evaluated to know what things are currently set to. So we'll see that in a second. So now this worked okay. So I don't necessarily want to run this again, but I want to create a new cell, and I can do that with this plus sign here. So if you hover over it, it says insert a cell below. So I'll click on that, and there's my new cell. So I'm going to get in the habit of writing a chunk of markdown code before every code cell. So, and I'm also going to try to break my code into separate functionality for each cell. So imports here, and then the next thing I want is to make a database connection. So this thing at the top is a level 1 header. This is a level 2 header. I'm going to make another level 2 header. So make that markdown. And then this is going to be a level 2 header. And here I'm going to make a database connection. And then I'm going to execute this and make a new cell. And then this is going to be a code cell. So here I'm going to make a connection. Now, I'm going to use PyODBC to do that. And I'm going to call the connect method. And if I type that much and then press Shift Tab, I get the doc string for the connect method of PyODBC. And so this shows me the documentation on this function. And it includes the parameters with the description and actually a lot of information. And I could Google this as well, but sometimes it's convenient to just have it available. I've also given you in the readings a link to documentation on using PyODBC to connect to a Microsoft SQL server. So you can look this up online, and I'm just going to try to remember what it is, and we'll see what happens. So I'm going to pass in a bunch of keyword arguments, and I'm going to store this connection in a variable called connection. And then I have to supply the server, which is going to be equal to cisdbss.pcc.edu, which you should remember from CIS 275. And I want a username, which is going to be 275 student, and a password, which is going to be 275 student, and a database. And I'm going to use, for this example, the names database. And then I also need to supply a driver. And to find the driver here, I'm going to be using MSODBC. So I'm going to look for driver MSODBC 17, which is the version of the driver I installed. And I'm going to be looking for something with curly brackets in it. So curly bracket. And let's try PyODBC. And here it is. So this is the name of the driver here. So I'm going to paste that in. And then whatever the return value is from executing this cell, that's what's going to get printed below the cell when I execute this. And so if I want to see the value of connection, all I do is at the end of this cell, I type connection. And that's this variable by itself. It's going to return the value of this variable. That will be the last return value from this cell. And that's what will get displayed below here. So if I go ahead and Control Enter to execute that, I get an error because I messed up one of these parameters. And specifically, it doesn't like the invalid connection string attribute 0, login failed for user, empty string. So this should be user instead of username. So let's try running it again. And this time I get a pyodbc.connection object as the value for connection. So that means my connection worked. So let's go ahead and add another thing. And then I'm going to use a SQL statement here. So let me go ahead and add some markdown. Execute, make this a level 2 header. Execute a SQL command. And let's go ahead and Alt plus Enter to make a new cell under there. And then here's where the main code is going to be. And I'm going to go ahead and create a variable called SQL. And it's going to be a multi-line text string. And then I'm just going to write SQL. So select, what do I want? I want name, not gender, name count. And I think that's going to be all I need for that. From all data, and I'm using the names database here, where name is equal to Mark. We'll say, or name equals Mark with a K, and gender equals M. So this will return all the rows where the name is Mark or Mark and gender is male, one for each year. And so I want to return the name, the year, and the name count. And then let's order by year. And then to actually execute that, I'm going to use the pandas read CSV query method, which we'll talk about in a couple of videos from now. So data frame is equal to pandas pd dot read SQL query, and then we pass in the SQL query as the first argument and the connection as the second argument. So you'll notice that connection isn't defined in this cell, but that's fine because connection is defined in this kernel. So when I execute this cell first, that means there's a global variable called connection that's defined in the kernel. And when I execute this next, I can refer to the value of connection, even though it's in a separate cell. So this should return a data frame, and then if I want to see the contents of the data frame, I can just type df there, and it will show me the contents of the data frame. So let's go ahead and execute this. So Control plus Enter, and it shows me that I've successfully retrieved a data frame. In the name column, there's either mark or mark. The year column has the year as a floating point, which is maybe not what I want. And same with the name count. This is also a floating point where it actually should be an integer. But that's close enough for now. So I have the data in a data frame. So let's go ahead and add another cell under here. And then let's go and make a markdown cell. And I'm going to reshape the data. And then let's go ahead and Alt plus Enter. So we have a new code cell. And then to reshape the data, I'm going to use a pivot operation, which you might know from CIS 276 if you took that, or 275. But we'll talk about the pivot command later on. So I'm going to go ahead and say, so wide data frame is equal to data frame dot pivot, and then the index is going to be year. And don't worry if this doesn't make a lot of sense, because it will. And then columns equal name, and then values equal name count. And I'm actually going to go ahead and put the cursor right there and type Shift Tab just to make sure I got this right. So index is none by default. So index, columns, and values. So that looks right. So let's go ahead and then print ydf and then execute this. So you'll see we went from having a name column with two values in it, year and name count, and then the index was just a number here, to the index is now year, it's in bold and it's on a different level, and then there's a mark column with the name count as the value and a mark column with the name count as a value. So this has been reshaped in a format that I can plot easily. So I'm going to go ahead and add a new cell under there, and then I'm going to plot the data. And since I've shaped the code this way, let's go ahead and Alt plus Enter. It's actually fairly easy to plot it. I just go ahead, actually let me execute this. Alt plus, oh, I have to change that to markdown. Forgot to do that. And then I have a couple of extra cells here, so let's go ahead and delete those. So cut that one and cut that one. Okay, so now to plot the data, all I have to do is say plot. Actually, I can say wide data frame dot plot, with no arguments. And since the data is set up correctly, this should work. So I'm going to go ahead and execute that with Control Enter. And so this plot command returns an axis subplot object. So this is a return value from the cell, and when I display that, I actually get a graph. So there's a simple example of working with Jupyter Labs, and we're going to flesh this out in a little bit more detail. Let me show you a little bit more markup though. So there's a link in the readings to a markdown cheat sheet. And basically you can do all the things that you would expect here. So under my example notebook, I'm going to go ahead and add a new line, and then let's go ahead and add a description of what the program is doing. So this program reads info from the, and then I'm going to italicize this by using a star around the word names database on cisdbss.pcc.edu. The connection info is, and then let's go ahead and use an unordered list. So we'll do dash space, and then bold is star star, username colon star star, 275 student, and then a next bulleted item, star star, password, 275 student, and then let's go ahead and do database is names, and let's do driver is this thing here. Okay, and then if I execute this, let me get rid of the extra line at the end. So I'm going to go ahead and do Alt plus Enter here. And that's what it looks like when it's formatted. And actually, I don't think I wanted to add a cell there, so let me cut it. Okay, so there's some simple formatting that you can do. Single stars around words, and you can also use underscores instead of stars. But single stars or underscores to italicize, double stars or underscores to bold, and then dash to get around bulleted item. You can also use star to get a square bullet, like so. Actually, I thought that was a square bullet, but it didn't seem to give me a square for some reason. And you can also make this a numbered list. So let's do 1 dot, 2 dot, 3 dot, 4 dot. So there's a numbered list. Now, I don't have to do anything to save this because it saves itself automatically. If I go back to my Python notebook, you'll see that every couple of minutes it saves the file, whatever the contents are, so all the changes get flushed pretty regularly. If you want to force it to save, you can now. You can either save the current notebook or save all. So just do Control S or select that menu item. And that's probably enough to start with for working with Jupyter Lab.